Okay, let's have a chat about outliers and what they are. So I'm sure you'll have looked at outliers in GCSE science. They're pieces of data that don't fit the general trend. They seem to be away from the rest of the data in some way. So this is a kind of more technical explanation, I guess. They're an abnormal distance from the rest of the data. Now, that's quite difficult to define because some data is really, really spread out. In that case, there might not be outliers. But let's have a look at this example. Where do you think the outlier is here? Well, everything seems to lie on a line, something like that, doesn't it? Apart from one, which is that one down there. That would be our outlier. It's kind of as simple as that. But what we need to know about is how to use a definition to be able to tell if something is an outlier. It's very important that you realize that there isn't a universal definition of what an outlier is. It's somewhat left to the discretion of the scientist who is collecting the data to decide what an outlier technically is. But in the exams, we often use this. So we say if a piece of data is less than Q1, so if you remember what Q1 was from earlier lessons, that's that 25% through the data. If a data point is less than Q1 minus 1.5 times the interquartile range, so that there is the interquartile range, or if it's larger than Q3 plus 1.5 times the interquartile range, then we'd regard it as an outlier. Okay, so to be able to actually analyze this, we need to know what Q1, Q3, and the interquartile range are for our data. So I've got a quick example here using a box plot to do a check of whether something's an outlier. So what we want to check here is, if you remember box plots, this one here, this is the minimum data point. It's the end of the whisker. This 39, the end of the other whisker, is the maximum data point. This is Q1. This is Q3. And this is the median here. What we want to do is, we want to be able to tell, is this 1 possibly an outlier? Or is this 39 an outlier? Or are both of them outliers? And we're going to check. So first of all, using this criteria, we're going to do Q1 minus 1.5 times the interquartile range. First of all, we need the interquartile range, don't we? So we'll do that down here. So interquartile range, if you remember, is Q3 minus Q1. That's 17 minus 5 if we have a look at our box plot, which is 12. We can now apply this bottom criteria. So Q1 is 5. If we do minus 1.5 times 12, that is actually going to give us minus 13. That's our lower limit. Okay, so I'll write it in big up here. So this is our these are our boundaries, if you like. If we have numbers that are beyond these boundaries, then they're outliers. So minus 13 is the bottom boundary. The other criteria is Q3 plus 1.5 times IQR. So Q3 is, so let's do that one here, Q3 plus 1.5 times IQR. Q3 is 17, so if we add on 1.5 times 12, which is the interquartile range, we get 35. That's our upper boundary. Okay, so anything that's not within that boundary, so between minus 13 and 35, we would regard as an outlier according to this definition we've been given. And it may vary slightly. Maybe it's 2 times the interquartile range or 1 times the interquartile range. The exam question will always give you the definition, because as I say, there isn't an official definition. Well, 1 is within that boundary, so this is not an outlier. Right here, so not an outlier because it's within, it's larger than minus 13, so it's not an outlier. However, 39 is an outlier because it's higher than 35, which is our boundary. Okay, so in this case, anything bigger than 35 would be regarded as an outlier. So 39, and we know there's a data point there because it's the maximum. 39 definitely is an outlier. Okay, so this is how we tend to look for outliers in AS statistics. Now, what's slightly complicated is we may think, well, if we found an outlier, we should just remove it straight away because because it's an outlier, it's an anomalous piece of data. But it's not always quite as simple as that. We've actually got some reasons we keep it and some reasons we might remove it. And there's some discretion involved here as to what we do. And it's important you understand reasons for and against, so that you could write about that in the exam. One reason to get rid of it is it's an extreme data value and it could influence the analysis. When I calculate my standard deviation, for instance, like we did in the previous lesson, that's certainly going to be influenced by having a value that's a long way from the mean. It's going to make my standard deviation much bigger. We've got to decide whether that's fair or not. It's certainly going to affect those statistics, and it'll affect the mean as well. So we might want to get rid of it to make sure it doesn't affect those values. However, it's still a piece of data, and we can't pick and choose what data to use. We need to consider all the data. Okay? So what we need to think about is how that piece of data that we think is an outlier, how did it arise? Was it a mistake or an incorrect measurement? Did whoever was doing the experiment read the ruler wrong or read the mass balance wrong? In that case, that's a very good reason to remove it, because it's not actually representative of what we're trying to collect. It's a good reason to remove it. But if we don't know whether it was a mistake, it might be the data is just quite spread out. It might be a valid piece of data, and actually it should affect the statistics. We should have a higher standard deviation because the data is very spread out. That's a judgment call we've got to make. If it's really far away from the mean, we have to think, was this because it was a mistake, or have I got pieces of data which suggest that this data is actually quite spread out and I should include it to get the right statistics? Okay, so it's not quite as simple as just it's an outlier, we should remove it. We need to have a think about whether we're being fair. Whenever we're doing scientific analysis, we need to think about whether we are being biased or whether we're trying to be as fair as possible. We're always trying to be as fair as possible. So we can't just get rid of data just because we don't like it. We have to have a good reason for it.